So that's what I want to look at for today. And the difference between series and sequence, not really big difference, but at least it's not the same thing, so that I will not mix it up. Let me share my screen so that this is serious. Okay. Okay, this is the first one, which is the series. So when we talk about series, what does it mean? This one says the sum of the terms in a sequence for finite sequences. The series is a number for infinite sequences. The series may be or may not be a number. So look at the example. This vocal, let's break it down. Now if you look at our sequence and series, the difference is the separation of those numbers. For our numbers in sequence, we use comma to separate it. So you can look at 2, 4, 6, 8, 10. We use comma to separate our numbers in sequence. But if you look at our number in series, we use the sign plus to separate it. So I can say 2 plus 4 plus 6 plus 8 plus 10 to give me that. So that's the difference between your series and sequence. So that's it, that under our series, under our sequence, we have two types of sequence. We have the AP and we have the GP. So the AP is the what? Arithmetic progression sequence, while the GP is the geometric progression sequence. So again, the difference between your sequence and series is just the way they separate them. For sequence, numbers are separated by commas, while for series, numbers are separated by addition. So moving on to, we have the arithmetic sequence, and I told you, I said we have two types of sequence. We have the AP and the GP. So the AP is the arithmetic progression sequence and the GP is the geometric progression sequence. Now let's look at the AP sequence. So talking about the AP sequence is a set of numbers generated by adding multiples of the common differences, which is D, to previous terms. So when you look at our AP, it makes use of two signs, addition and subtraction. That is the sign that we use in AP. So we use our AP, like we get the next number for our AP when you add our common difference to get the next one. So if my first term is 1 and my common difference is like 2, I will add 2 to that one to make it 3, so that we get the next term. So I repeat again, under your AP we make use of two signs, which is addition and subtraction. So look at our arithmetic sequence. There's something we call the first term, the second term, the third term, the fourth term, the fifth term, like that, like that, like that. So when we call the first term, there is a letter that we need to represent, which is what? A for first term. Then for the second term, don't forget we said to get the next term, we are going to add what? Our common difference to it. So if my first term is A, to get the second terms, I will just add what? D to it. This is what I'm saying. So if the first one is A, so to get the second one, I'm just going to say A plus D. I will add D to that one. Then to get the next one, I'm going to have 2 of D. So it's going to be, because D is there already, so I will add another D to it. So to get the next one, it's going to be A plus 2D. That's how you get it. To get the next term, A plus 3D. To get the next one, A plus 4D. Like that, like that, like that. That's how you keep going to get the term. So now there is a general formula that we now use to get any number of terms. There is shortcut, there is general formula. So the general one that we use, some people, you can see they will say Tn. They use the word Tn, that means number of terms equals to A plus n minus 1 in bracket, and I will have D outside. So this is the general formula for generating our any number of terms. It can be first term, second term, third term.
I don't know, got some serious here.
Sorry, who is that? Please mute yourself. Thank you. So you can use to get any number of terms. Your Tn equals to a plus n minus 1. So you can use to calculate any number of terms. Then the shortcut is by subtracting one number from the common difference. So if I'm talking about the second term, normally for second term I'm supposed to have a plus 2d if I want to do it because I'm in second term. But the way we get it is always decreased by 1. So instead for me saying 2, I know that okay, if I'm in second term I'll take away 1. So I'm going to have a plus d. If I'm on the third term I'll take away 1. So instead of a plus 3d, third term take away 1 from the d. So I'm going to have a plus 2d. That is the shortcut. So if you use the full one too, you can get the normal solution for that. Are we together? Are we together? Are we together? Okay, that's good. So let's continue. So moving on to arithmetic sequence, we are still under the AP. What are the key points that we must know? What are the key points that we must know? So if you look at number 1, the first one is definition of arithmetic sequence, which we've done that. We've done justice to that. Then there is a common difference between any two consecutive numbers. There is a common difference. From the word common difference means you take away, difference means minus. So there's a common difference between two consecutive numbers. So between between the first number and the second number, there's a common difference there. And that thing is denoted by what? Letter D. So we use letter D to represent our common difference. Then anytime we want to talk about first term, we use A for first term. So under your AP, which is arithmetic sequence, we make use of two letters, which is very very important. Is the A and D. A and D. That is the letter that we use mostly in under AP. We use A and we use D. So the A means the first term, the D means the common difference. So the second one say notation of terms in arithmetic sequence. So there is number of terms. There's something we call first term. First term is the first number you are going to see. So in a place when I have 1, 2, 3, 4, this is a sequence, right? Now the first number I'm seeing here is what? Is 1. So it means this one, since 1 is the first number I'm seeing, 1 stands for the first term. Since 2 is the second number, it is called second term. Since this 3 is the third number, it is called the third term. And since this 4 is the fourth number, it is called the fourth term. That is just the meaning. And this one is there is a particular thing that produces it. So what number of term? So if I say first term, I know that A means first term. If I say second term, I will know that A plus D, which stands for second term, is equal to this number 2. So that is the meaning. So A plus 2D equals to 3. A plus 4D equals to A plus 3D equals to 4. So that is how we are going to get that. So moving on. Look at our notation here. We have A plus D, A plus 2D, A plus 3D until we get to what? Nth term. And I've told you that the number for calculating our nth term is A plus N minus 1 into bracket. Then you have your D outside. So the next one is the third one. Nth term or a general term of an arithmetic sequence. You can see they've given us that it is what? A plus into bracket N minus 1 close bracket D outside. Then sum of the first n terms in an AP. There's something we call sum of AP. We are familiar with it, which is n over 2 into brackets 2a plus n minus 1 close bracket. Then you have your D outside. So moving on. Sorry. Okay. Now I think the next one is GP. Now before going to the GP, in case we are giving the last term, there is a way we calculate it. So it has a formula. So for last term, our L is equals to, so instead of us having N or Tn, we are going to have L. So it's the last term we are going to use. So N equals to, you still have the same thing that says A plus N minus 1 in brackets. Then you have your D outside. So you still have like this, but we are going to have the L term. But the difference is for the sum, it is different. So if they give you last term for sum of AP, it has its own formula. So you're not going to use this fourth formula, this formula here. You will not use it. You will not use it if last term is being given. So this is what you are going to use. That Sn, that is the sum of the term we are talking about, equals to n over 2a plus l. That's all. Okay. So you can say Sn equals to a plus, sorry, equals to n over 2, then into bracket a plus l. So you say Sn equals to n over 2, then a plus l. So in case the last term is being given, this is the formula I'm going to use for the sum of the AP if last term is being given. But if there is no last term, we are going to use the normal one, which is the Sn equals to n over 2 open bracket 2n plus open bracket n minus 1 close bracket d, and close the big bracket. So any questions so far before we move on? Any question from anyone? Any question? I think some people have network issues. You just have to deal with it. Sorry. Any question? Joseph, are we still together? Okay, so let's continue. The last part of the AP that we still need to share, the last part of the AP is the arithmetic means. Arithmetic means. And this one says, what if I have a number like 2, 5, 7? How will I get the arithmetic means? To get the arithmetic means is just, for example, is like saying I have A, B, C. So what I will do is that A equals to, I'm going to have B plus C together, and I'll divide it by 2. So this is the last part of AP. So everything on AP, we've discussed that. We've discussed the meaning of AP. We've discussed the number of terms in AP, the last term, the arithmetic means, and the sum of AP. So let's check questions on that. Or I don't know, maybe I should move on to GP. Let's move on to GP. So this one is the second type of the sequence. We have two types of sequence. I told you we have the AP and we have the GP. Now coming back to our geometric sequence too, is the same thing, but it's just that this one it uses 2 letters, and 2 letters that this one uses, it chooses A, which is the first term that is common to both geometric and arithmetic. A. So this one uses A and R. So instead of G, you choose R. And the 2 signs that is very peculiar to your geometric sequence is multiplication and division. That is it. So this one uses the two signs of multiplication and division, while your arithmetic progression uses 2 signs of what? Addition and subtraction. So that is what the way it will increase. It increases in form of addition, while your geometry increase, sometimes we call it exponential. So anything exponential is like multiplication, so it triples, it doubles. That is how it increases. So we have the times and we have the what? The division. That is the 2 signs that we use for geometric sequences. Then another thing also is what? A is still there, which is what? And A still means the same thing. It's still common, it's still the first term, but your R here means common ratio. But for our D in our AP, it means what? Common difference. But here means common ratio. So you should know that if I want to get my common ratio, if I want to get my, there's a way I will do it. Now let me go back to AP. Now to get our common difference, we are very familiar with it, but don't let me assume that we know it. Let us assume that we don't know it. So to get our D, which is the common difference, what we are going to do is you always subtract the second term. Please always subtract the second term from the first term. Some of us, we see something like 2, let's say 1, 0. So you now look at, oh, since my second term here is small, let me say 2 minus 1. It is wrong. The formula is always the second term minus the first term. Don't change the pattern. So either the second term is lesser than the first term, or the second term is higher than the first term. We follow the formula that says the second term must always subtract the first term. So here it's going to be 1 minus 2. So my common difference is going to be minus 1, a negative 1. not 1. So don't interchange because the second one is lesser than the first one. You don't do it that way. The formula, the way to get our common difference is by subtracting the second term from the first term. That is the formula. So how do we get our common ratio? This one we divide. So if I have like 3, let me say I have 9, I have 3, I have let me say 0 here. So I'm going to divide. That's what I will do. I will divide to get our common ratio. You are going to divide the second term over the third term. Over the first term. You know that one too we use for second term and first term, but the difference in the AP is what we use subtraction, but in GP you use division. So we are going to, it's going to be 3/9. So that is how to get it. So that one is going to be 1/3 for your common ratio. So we divide the second term by the what? By the first term. Don't say because your second term is less than the first term and that one wants to manipulate. No, don't manipulate anything. Leave it as it is and follow the formula that says for every common ratio, it is always the second term divided by the what? The first term. That is how we calculate it from now. So don't change it. So moving on, what is geometric sequence? A geometric progressions are other set of numbers that progresses by what? Multiplying or dividing. You know that I told you it's made of two signs, multiplying or dividing each term by the same amount each time. The amount is called a common ratio. Now another thing is when you check your sequence in AP, I must have the same common difference between the second and the first, the third and the second, the fourth and the third. My common ratio must be my common difference must be constant. So it's not like between the second and the first I will get my common difference to be maybe 2. Then between the third term and the second term I will get common difference of 5. That one is not an AP and it's never what? It's never a GP as well. So to get your GP, your common ratio must be constant. To know that okay, this sequence is an AP, your common difference must be constant. So that is just what we are trying to say here. So we have 1, 2, 4, 8, 16. You can see that if I try to get my common ratio here, what's my second term here? 2. So I'm going to have 2 over my first term is what? 1. So my common ratio is what? 2. To get it for the between the third and the second, my R is going to be what is the third one? 4th over second, which is what? 2. So I'm going to get what? 2. You can see my common ratio is the same thing. 8 divided by 4 I'll still get 2. 16 divided by 2 I'll still get 2. So if you look at everything, it increases by 2. My common ratio is constant, which means it is a what? It is a geometric progression. Check the second one too. If you check this part too, we have 20, 10, 5, 2.5, 1.25. By the time you check it, you see that I will have the same thing, which is 2. 10 divided by 20, sorry, I'm going to have 1/2. Then 5 divided by 10, I'm going to have 1/2. So if you check it, you see that my common ratio is still what? Is still constant. It shows that it is what? It is a geometric progression. Then we are still talking about the geometric sequence. A geometric sequence is one where to get from one term to our next to the next, you multiply by the same number each time. The number is called the common ratio. Just like what we explained, that our common ratio must be constant. So you can see the common ratio here is what is R. And if you can see that from the first to the fourth terms, they increase by 5. So by multiplying by 5. Then the next one is still okay. We are trying to check determine whether the sequence below are geometric or not. So 1, 3, 9, 27 with 1. If you divide 3 divided by 1, that is second term divided by the first term. You are going to have 3. You are going to have 3. So we are going to have 3. Then 9 divided by 3, I'm still going to have 3. 27 divided by 3, I'm still going to have 3. 81 divided by 27, I'm still going to have 3. So as long as my common ratio is 3 and it's the same thing all through, it's a geometric sequence. If you check the second one, 16, 8, 4, and 1. 8 divided by 16, I'm going to have 1/2. 4 divided by 8, I'm going to have 1/2. But 1 divided by 4, I'm going to have 1/4. So that last one is not giving me the same common ratio, which means what is what? Not geometric. Then we check the third one, it's geometric. Check the next one, is geometric as well. So this is the sum of AP. We've done that before. So in case you want to write it down, this is sum of AP. This is sum of that. And no, that is sum of AP. We say that what's the meaning of SN? That is sum of the term of the AP. The A means the first term of AP, not first term, first form. It's the same thing. Then the D means the common difference. That is the D. And the N means what? Number of terms. So okay, now coming to the sum of the first AP. Now we have two formula for our GP. Two formula for the sum of GP. our common ratios can be greater than 1 or it can be less than 1. So if my common ratio, which is r, is greater than 1, I'm going to use the second formula. But if my common ratio is less than 1, I'm going to use the first formula. So since it is less than 1, you can see that it is 1 that will first come. 1 will come first. So I'm going to have Sn equals to a into bracket 1 minus Rn, you close bracket, over 1 minus r. So my 1 can never be equal to 1. So when my r can never be equals to 1. So if my r is less than 1, I'm going to have a into bracket 1 minus r raised to power n, then over 1 minus r. But if my r, which is common ratio, is greater than 1, I'm using the second formula. Then we also have geometric mean. The way we have arithmetic mean, our geometric mean, this way of having is you are going to multiply the two numbers they will give you together and you find the square root of it. So if I, for example, if I have a number like let me say I have, okay, maybe I have number like let's say 2, 5, and they ask to look for the 2 and 5, and I say I should look for the geometric mean. What I'll just say is that s equals to, I'm giving the two number, so this should be my a is 2 and my b is what, is 5. So I'm going to have square root of 2 multiplied by 5. So my x is going to give me square root of 10, and I'll get my answer. So that is how to calculate the geometric mean. I think, let me check, I think I still have one more this thing. Okay. Okay. Okay, let's solve this question. The third and the fifth term of a geometric series are 5.4 and 1.944 respectively, and all the terms in the sequence are positive. So from this series, find b, the common ratio, c, the first term, then d, the sum of infinity. So sum of infinity is this. This is form of sum of infinity. This is infinity sign, so is equals to a over 1 minus r. So you can put it down. That is the sum of infinity. S infinity equals to a over 1 minus r. So let's try this. I don't know who is online, so I'm giving you. Okay. Okay. Let me. So if you want the third and the what and the fifth term of geometric series, the third term of geometric series is the same. I don't know, maybe because I don't really want to, but let's just, so to get our number of terms in GP, we are going to have n term equals to AR n minus 1. That's to get our number of terms. So let's say I want to get the formula that I'm going to use for let me say for fourth term. So okay, what is the formula I will now use for the fourth term? So I know that my n here is what, is 4. So to get formula for the fourth terms, this is what I'm going to do using this formula, which says n is power minus 1. So I'm going to have 4 term, right, equals to, I don't know, a. So r, what is my n? It is 4 minus 1. So I'm going to have fourth term to be what, ar cube. So that's how to get first term. It's still the same like your AP that I told you that for a common difference you will reduce it. So the number of terms that you have, you are going to reduce by 1. So same thing for our GP too. Since I'm in fourth term, I'm going to reduce my common ratio by 1. I will reduce by 1. So I'm going to have r raised power 3. So if it is fifth terms, I'm going to have this is what I'm going to have with the fifth terms. So for the fifth term, don't forget, I'm going to now have a raised power what? 5 minus 1, that is what? 4. So this will be the formula. So a raised power r is the fifth term. Then to get the sixth terms, I'm going to have AR raised to the power 5. To get the 7 terms, I'm going to have AR raised to the power 6. So if I say that, okay, I have AR raised to the power 7, I know that I'm in what? 8th term. If I have AR raised to the power 8, I know that I'm in what? 9th term. So that is how to get it. So now, coming back to the question here. Coming back to the question. So the third term, so I know that my third term is what? AR square, that is enough third term, equals to 5.4. And the second one says, and the fifth term is what? AR4, because they are in geometry, that's how I know that I'm using AR, equals to what? 1.944, equals to 1.944 respectively. And sorry, what's there? Okay, and the number of terms in the series are positive. So that's also find the A. Sorry, let me look at what they asked us to find here. A says find the common ratio. So AR4 is equals to 1.944. So we are looking for R. So to get this one, we are going to, this one is like equation 1 and this one is equation 2. So what we are going to do is we are going to divide equation 2 by equation 1. You divide equation 2 by equation 1. So if I want to divide equation 2 by equation 1, that's going to be AR raised to the power 4 over AR raised to the power 2, then equals to 1.944 divided by 5.4. So that is what I'm going to get. That's what I'm going to get. So if I want to divide it now, so I'm going to have AR raised to the power 4 divided by AR raised to the power 2 equals to 1.944, sorry, then divided by 5.4. Let me write it so that we'll get it. 1.944 1.944, then divided by what? 5.4 divided by 5, sorry, divided by 5.4. Okay, okay. So I make use of my calculator. So if you look at this now, so I'm going to have A divided by A. Do you get? Then this one, this we cancel this, that is the square. We're going to have R raised to the power 2, right? Then if you divide this by this, we are going to have 0.36. 0.36, that's what we are going to have. So going back, so I'm going to have, now I have what? Sorry, I have R square then equals to 0.36, and to get to R, we all know you do the square root. You do the square root. So I just want to confirm, because sorry, let me try to manage my space. So we are going to have the square root of this, then equals to square root of 0.36. So this we cancel this, and at the end of the day, our R is what? 0.6. So our R is 0.6. Now I've got for this to be what? 0.6. The next one is what? The first term. So you can go back to any of your this thing that says AR cube equals to what? 5.4. So by the time you insert it, sorry, okay, because that is the second term, that is Sorry for this. So r is this 0.6. So to get our first term now, so I can use either the third term or the fifth term. I can use any of them. So I'm going to have ar square. I'm using the third term equals to ar square equals to 0. Sorry, 5.4, right? It's equal to 5.4. So I know my a to be what? 0.6. Then into bracket what? R square equals to 5.4. Let me see, maybe I can get a white testing. Look for a whiteboard. It's like I have whiteboard, so that's what I'm trying to. Don't know where this meant to. Okay. And I have whiteboard. So we stop at, we've already gotten our r, that our r is 0.6, right? Okay, so we have to find the first term, and the first term says what? So I said I want to use the third term, which is ar square equals to 5.4 from the question that we are coming from. So by the time I do that, I already know that my a is what? 0.6. So I'm going to have a, sorry, so I'm going to have 0.6 into bracket what? R square equals to 5.4. Equals to 5.4. 0.6 R square equals to 5.4. Then you divide both sides by what? 0.6. So your R square is equals to 9. Then what you are going to get next is what? You find the square root of this. So our R is equals to, sorry, we are looking for a. I don't know why I'm very familiar with it. We are looking for a. So that should be a into bracket 0.6 square. Do you get? Then equals to 5.4. Equals to 5 point. You know r to be this. And we are using ar. We are using ar raised to power 2 equals to 0. Equals to 5.4. Because that is the formula for the third term. So I know my r to be 0.6. So I'm going to say, so is a we are looking for. Don't make that mistake, please. So is a into bracket 0.6 square, then equals to 5.4. 5.4. So our a is now going to be 5.4 divided by 0.6 square, or divided by 0.36. Let me use black. So a equals to 5.4, because 0.6 square will give us 0.36. So by the time you divide it, you get your final answer. Eh, that's the answer. So I want to get the next question. I want to get the Oh, I think that I've moved myself. Oh God. So this one is, I'm trying to sort it out. This one is handwritten stuff, so that I will not mess it up. You just get it once. Okay. So sorry for the noise, because of, that we are in festive period and everywhere is just rosy rosy. Okay. I think I've sorted this out. Okay. This is the question I want us to look. Find three numbers in arithmetic progression whose sum is 21 and whose product is 315. I'm trying to pick some delicate, because I don't want to be dwelling in this normal one. Everybody, we are very familiar with that one. The first term is 3, the second term is this. What is it? So we are very familiar with those simple one. And it's a thing that if we want to read it on our own, we can still get it. But let's do some uncommon type of this thing, like the one that we just solved. Oh, sorry, even the one that we solved, we've not done the sum of infinity. After this, I'll go back to that, please. I just remembered. So find three numbers in arithmetic progression whose sum is 21 and whose product is 315. They did not really give us the we don't know, but they just said find three numbers in arithmetic progression. But this statement already has made us know that, oh, we are coming from arithmetic progression. That's where we are coming from. So I know that what I want to do will be in the form of what, a linear process, and I know how to do it. So what I'm now going to do is, oh, they say three numbers, so that means I'm going to form it myself. If I know that my first number, I know that, oh, my first term is A, the second term is what, A plus D. Now to get the third one, I'm going to use the inverse of this last one here. So the inverse of A plus D, don't forget that in your AP we use what, addition and subtraction. So the inverse of addition is what, subtraction. So I'm going to have A minus D. So since I'm going to have A minus D, so this will be my three numbers. So I'm going to have the A minus D, comma, I'm going to have the A, comma, and I'm going to have the A plus D. I'll do it. I'll explain again. Find the three numbers in arithmetic progression. I don't know the three numbers. Now let me now assume that, okay, the first one is first term. Since I don't know the actual number, but I can know the number of terms. So they've given me that it is three numbers. So I know that, oh, I'm going to have three terms. That's just the meaning. But I don't know what that number of terms is going to give me, the final answer for that number of terms. I don't really know, but I know that, oh, I'm going to have three terms. So if my first term is A and my second term is A plus D, now to get the third one, we are going to use the inverse of that A plus D. So the inverse of A plus D is what, A minus D. How do I know? In AP we make use of just two signs, addition and subtraction. So since it's two signs, so the opposite of the plus is what, minus, while the opposite of minus is what, plus. So I'm going to have the A minus D. Now because A minus D is not part of the what, is not part of AP, let me say, it's not part of what we use, it's not part of the terms, it's not part of the things we use in AP. So we are going to bring it first. So from that place, it's going to increase to A plus D. And since it's even A minus D, which means it is less than what, A plus D. So I'm going to take it first. So I'm going to have the A minus D, I'm going to have the A, and I'm going to have the A plus 2D. So these are the A plus D. So these are the three numbers I'm going to have. So I've done the solution. So I just want to, so that you will understood what I'm trying to say. Sorry. So I understand better. So moving on, you can see the solution that we are going to have. So that is how we got the A minus D here. So A minus D will be the first term, the A will be the second term, and the A plus D will be the next term. So moving back to this place. Now let me break down to what they asked me to do. They said find three number. Okay, we've done that one. So we've found the three numbers. Now the next one, he said whose sum is 21. That means I'm going to add these three numbers together. That is sum. So if I add them together, they'll be equals to this 21. That is the English. And whose product means I'm going to multiply these three again together, and I'm going to have 315. So let's do it one after the other. So let me first solve for the sum of it. So to get for the sum of it, you can see it here. So this one, say, let me crop it so that we will not mix it up. Okay. So to get the sum of these three, I'm going to add it together. That means a minus d plus a plus a plus d. Don't forget that I have a minus d first term, a is the second term, then a plus d is the third term. Then everything, if I add them together, is equal to what? 21. So because of that, I'm going to have a minus d plus a plus a plus d equals to 21. Minus d and d will cancel out. So I'm going to have a plus a plus a, which is 3a, equals to 21. So divide both sides by 3. I'm going to have 7. So my first term is what? 7. My a here is 7. So since I've gotten my a to be 7, I can also move on to the second part that say the product is what? 31. That's what the product says. The product is 31. So I've done for the sum. So if the product is 31, that means I'm going to multiply the 3 together. So a will multiply a plus d, and we multiply a minus d. I'm going to have 315. So I'll first multiply this out. So if I multiply this out, it's going to give me a square, right, plus minus ad, right, plus ad, right, minus d square. So minus ad we cancel plus ad, so I'm going to have a square minus d square left, right. So that is how we got about, so that is how we got this. So this a, so after I simplify the a plus d into bracket and a minus d, I have at what? A into bracket. The a, don't forget, the one a is still outside though, because we are trying to, sorry, I don't know what is wrong with this. Okay, so we are trying to get the, we're trying to multiply the 3 together. So since we multiply the 3 together, so I first express these two, because these two are in bracket. So I first express this. So after expressing this, my 2, my a is still outside. Now I know from what I solved before, so don't forget that we already find that our a is what? 7. So my a can be 7 outside there. So 7 into bracket a square minus this. I can decide to express everything at once. So my 7 is outside, open bracket, a square minus d square, close bracket, equals to 315. So I'm going to divide both sides by 7. I'll divide both sides by 7. So I'll divide this by 7. I'll divide 315 by 7. So by the time I divide both sides by 7, I'm going to have a square minus d square equals to what? 45. Equals to 45. So after that, don't forget my a is still what? 7. So I will express my a. So I'm going to have 7 square minus d square equals to 45. So 7 square will give me what? 49. 49 minus d square equals to 45. I'll collect like terms. So I'm going to have 49 minus, 49 minus, where is this? Okay, 49 minus 45 equals to d square. So 49 minus 45 will give me 4. So I'm going to have d square equals to 4. Square root of both sides. So my d can be what? Plus or negative 2. And since it's arithmetic progression, we go for the plus 2. We go for the plus 2. So where is the, okay, we go for the plus 2. Now we already know, so we've solved it that, okay, our d is what? Plus 2, and our a is what? Our a is 7. So from there I can get the 3 numbers that they asked me to get. That what is the 3 number? So my 3 number is 579. How do I come about that? So since I'll still follow my what? I'll still follow my sequence that I formed, which is a minus d, a comma, and a plus d. So now I know that my a is what? 7. So I'm going to have 7 minus, what's my d? My d is plus 2, but there is minus here, so minus times plus will give me minus 2. So 7 minus 2 will give me 5. I know my a to be 7, and a plus d will be 7 plus 2, which is what? 9. So my sequence here is 5, 7, 9. It's not hard. It's very simple. It's not hard. So that's how to get it. I've told you how to get that first one. You can also have it for the GP. If it's for the GP and they ask you to form the 3 sequence too, this is how I'm going to form it. If it is GP, I will look for a question on GP so I can solve it. If it's GP and they ask me to form the 3, I'm going to have a, don't forget, sorry, you are going to have the first term is what? A for GPO. The second one is going to be AR, right? Now if I'm going to have AR, don't forget, I said, what will you do? You are going to reverse the last one. The AR is the last one. So if you reverse it, don't forget this is GP. It makes use of two signs, which is what? Multiplication and division, right? Now from this place I use multiplication, which is what? A times r, to have the AR. Since I use multiplication, the inverse will be what? Division. So I'm going to have the A over R here. So this is what I'm going to have. So this is my 3 number. I'm going to have A over R comma A comma AR. So let me look for before I move forward. I said that one that we are trying to solve, we didn't finish it. That they asked us to find the sum. Where is that? Okay, yeah. Okay, we've calculated for the first one, the first term, for the common ratio to be 0.6, and for the first term. Now they asked us to find the sum of infinity. The sum of infinity. They asked us to find the sum of infinity. I'm coming. I'm trying to do. Yeah. Okay. Is it sharing? Okay, it's not yet sharing. Okay, the sum of infinity that I told you, that one is x. Sorry. I okay, the a that we are trying to calculate, you know that I said the a is equals to, we got what? 5.4, right? Then we said 5.4 divided by 0.36. So 5.4 divided by 0.36, a is 15. A is 15. So now we got our a to be what? 15. We get our a to be 15. So if our a is 15 now, we got 15 for a. What happened? Am I not sharing my screen? Abdul Kalim, thank you. Stop sharing your screen so that I'll be able to share mine. So I think we are still together. Okay. Mind my. So the sum of this will be a over what? Sorry, I was trying to explain that before we move. Where we stop then, when I explained that, I said a equals to 5.4, we divide by what? 0.6 square, and 0.6 square give us 0.36. So therefore a is what? 15. Now I know my a to be 15, and I know my r to be what? 0.6. So 0 point, my a is my a is what's my a? My a is what did I get? Sorry. 15, right? I was a bit distracted with that message. So my r is 0.6. 0.6. So now I'm going to do my sum of infinity. So my sum of infinity is a over 1 minus r. So sum of infinity is going to be, what's my a? 15 over 1 minus what? 0.6. So from there I'll calculate my sum of infinity. So let me go for another question. I've seen one that we can also look at that can be a bit complex. I've seen one. I've seen one. Trying to read it soon so that